Okay, today we're going to learn about factoring using the box, and this is a tricky topic. It's not difficult, but it's got a lot of steps, and you got to make sure that you're paying attention and being careful as you work through them. So I want us to recap a couple of things. First of all, standard form. So we're working in standard form. Up until recently, we've been working in kind of exclusively vertex form, but now we're going to be using standard form exclusively. I mean, and honestly, vertex form was all I ever used when I was a kid. So we're kind of going back to normal for me. That standard form is ax squared plus bx plus c. When we factor, we have to be in standard form. Okay, and it has to be ax squared plus bx plus c from the highest order exponent down to the, so we need a quadratic term, a linear term, and a constant term. It has to be like this, or else the box doesn't work. Okay, so the other thing is to remember, just like yesterday when we undistributed, when we were doing factoring yesterday, when we were doing the GCF stuff, the GCF is going to be part of our answer. We don't throw it away. It stays as part of our answer, so don't forget about it. Write it somewhere so we know that it matters. Okay? So I'm going to do 4 examples, okay? And then we're going to do a ton of examples in class tomorrow, okay? I'm going to show you this process. Again, the process looks daunting, but really it's just, you just have to practice it and learn it. And once you learn it, it's actually really easy, and you'll start to get really fast at it. We're going to practice a ton. Okay, so we're going to start with the first problem. And factoring, what factoring is up until now, we've been multiplying. So we took 2 binomials, we multiplied them together to get an answer. In fact, why don't we start with that? Okay, let's say we start with x minus 5 times x plus 2. We're going to end up working the same process backwards. Okay, so if I want to multiply this using the box, and we are using the box, so if the box is not your favorite method, that's what I'm teaching you. Okay, the other method, like I told you in class, is guess and check, and I will never teach that. Okay, so what do we start by doing? We start by putting our factors on the outside of the box. So x minus 5, x plus 2. Okay, and then we multiply. So we distribute this x to everything here. We distribute this 2 to everything. So we get x squared minus 5x, 2 times x is 2x, 2 times negative 5 is minus 10. And then we combine these and we get an answer, x squared. These combine to minus 3x minus 10. So that's how we multiply binomials. That's what we've been doing. We've been going from the outside in. Now when we factor, we're going to go from the inside back out again. Okay, we're going to do this by using GCF. There's going to be some, I don't want to say guessing, but there's going to be some elements where we have to figure out what factors we're going to use. Okay, so watch this process. Okay, so now we're looking at x squared minus 3x minus 10. What we're going to start by doing is, first of all, we want to make sure that this is in standard form. That means ax squared plus bx plus c. And again, it doesn't matter that these are plus or minus. It means I need my squared variable, so I need my quadratic, then my linear, and then my constant. So first, I'm in standard form, okay? And the next thing I'm going to do, I'm just going to jot down A, B, and C, because I'm going to use them in a minute, okay? Well, I don't see a number in front of A, so it's an invisible 1. The coefficient of the squared variable, which is B, is, I'm sorry, the coefficient of the squared variable is A, that's 1. This coefficient of the linear term is negative 3, that's my B, and the constant is C. Okay? So now, knowing that I'm going to be going from the inside of the box out, I need to draw a box. Okay? Now I call this the BoX with a big X because we're going to use a little X over here to help us out. Okay? So, first thing I do is I put the squared variable, because remember, in this problem up here, the squared variable is always in the top left corner. So I'm going to put the squared variable in the top corner of the box. The constant always ends up in the bottom right corner, so that's where I'm going to put the constant. So when I first start by setting up the box, I put the the x squared. I put the squared variable in the top left. I put the constant in the bottom right. Okay? So far, so good. The next thing we need to do is figure out what a times c is. A is 1, c is negative 10. A times c is negative 10. Okay? And we're going to make an x right here. A times c goes up here. And we're going to put b down here. So what is b? b is negative 3. Now, what I want to do is I want to find numbers that multiply to give me negative 10, but add up to negative 3. Why is that? Because I have to multiply, I need these two terms to add up to 10. I need to know what two numbers multiply. See, 2 times negative 5 gives me negative 10. 2 plus negative 5 gives me negative 3. So I need them to multiply to a times c, but I need them to add up to b. So we can make a little table over here, okay? So we need them to multiply to negative 10. So that's negative 1 times 10, negative 2 times 5. That's it, okay? Well, negative 1 plus 10 is 9. Negative 2 plus 5 is 3. That's not right, but it's close. I want it the other way. So what if I do 2 times negative 5? Is 2 times negative 5 negative 10? Yes, it is. Does 2 plus negative 5 add up to negative 3? Yes, it does. So the values I want are 2 and negative 5. If you're confused right now, that's okay. I want you to watch this process, okay? I'm going to do a bunch of examples. I want you to watch this process. This is a brand new tricky concept, okay? So don't freak out. So now that I've figured out what numbers multiply to give me negative 10 but add up to negative 3, I'm going to take these two numbers, I'm going to stick them right here. Okay, with an X after them. Notice, this matches my box. It matches what I have in my box. So this matches what I got into my box. When I find those values, those multiples, they multiply to give me the constant, but they add up to give me the b. That matches exactly what I put into the box. Okay? So now I've got the box filled out, but what I'm trying to get are the outsides of the box. How do I do that? I do that with the greatest common factor. Okay? What is the greatest number that these two have in common? Well, this is 2 times x. This is negative 1 times 2 times 5. 2 is what they have in common. Okay? This one, I have x times x and negative 5 times x. X is what they have in common. Now, if this number here is positive, then so is that. If it's negative, so is that. Okay? So now let's look here. I want to know what this whole column has in common. Well, x times x, 2 times x. They have an x in common. Negative 5x and negative 10. Well, negative 5 times x, negative 5 times 2. Negative 5 is what they have in common. So that equals x plus 2 times x minus 5. Okay. I want you to pause the video. In fact, I'm going to make the video pause for a second. I just want you to think about what you just saw. I know it seems like a lot, but I'm going to do some more examples, and we're going to work through a whole bunch of these. We're going to do a ton of them tomorrow. Okay? The process is complicated, but it's not actually, the math you're doing is not very hard. All right? So we're going to pause real quick, and you're going to just think about it. Okay. So let's try another one. Okay? 2x squared minus x minus 3. And I'm sure a lot of you wondered why you said, well, 2 times negative 5 is negative 10, so why am I doing a times c? Well, that's fine when I don't have something in front of the a value, but when I have something in front of the a value, it changes what I get out of the box. So that's why I have to do a times c. So is this in standard form? Yes. Do I have, and I didn't say this on this one, but do I have a greatest common factor? If the greatest common factor is 1, awesome. Okay, that doesn't matter. If the greatest common factor is something else, then I'm going to have to take that greatest common factor out first. Well, 2x squared, negative x, these don't have a greatest common factor. So I'm going to write no GCF, just so I know I checked for it. And then I'm going to write down what A, B, and C are. Okay, well, I'm going to put my invisibles here. A is 2. B is negative 1, C is negative 3. Okay? So I'm going to fill in the box. Well, I'm going to make a box. And then I'm going to fill it in. I'm going to put the x, the quadratic term in the first box. I'm going to put the constant term in the last box. And then I'm going to multiply the a times c together. 2 times negative 3 is negative 6. Okay, when I make my x, negative 6, so a times c goes on the top, and b goes on the bottom. Again, so now what I'm looking for is I'm looking for things that multiply to give me negative 6, but add up to negative 1. So I'm going to make myself a little factor table again. Negative 6. So that's going to be negative 1 times 6, negative 2 times 3. I'll just do them all. Negative 3 times 2, negative 6 times 1. Okay? These are all the ways that I can get negative 6 by multiplying two numbers together. And I'm looking for whole numbers too. Don't be looking for fractions. Okay? Now I'm going to add them together because I want the factors that add up to negative 1. Well, negative 1 plus 6 is 5. Negative 2 plus 3 is 1. Negative 3 plus 2 is negative 1. Negative 6 plus 1 is negative 5. Well, I want negative 1. So these are the numbers I need. So I'm going to put negative 3 and 2 there. Okay? So then in my boxes here, I'm going to put negative 3x and 2x. It doesn't matter where I put them. I could put the negative 3x here and the 2x here. All that matters is that they're in these diagonals. Okay? And if I look at the box, I can tell that I've got the box filled in correctly because 2x squared, 2 plus negative 3 is negative 1x, negative 3. And so if I were to just write down what I see in the box, it's that. So I know I filled in the box correctly. Now I need to pull out the greatest common factor of each row. Well, what do these two have in common? Well, negative 3. 2x squared, 2xx, and 2x. This one has 2x in common. This one, they don't have a number in common, but they both have an x. And this one, they don't have anything in common. They have a 2, an x, a negative 1, and a 3. So when they don't have anything in common, we put plus 1. Okay?